Welcome everyone to the online lab sessions. I hope that these lab sessions are going to give you some break or relief to the normal theory classes which are going on. So though it is once again it's an online class, and you may tell me that these are also online classes. So how this can be a break? But actually, I think that the normal classes which are going on, those are also theory classes. Nothing, to, rather, to watch out some sort of observations going on. Not really like that. But these classes, over here, we're definitely going to see some reactions going on, some experiments being performed, and the observations we are going to look out. So definitely, it will be a valuable thing to watch out. So let's see what we are having going to do today. Moving on to our experiment section. So let's check it out.
Good morning. Good morning, students. Today, this is a special class once again. I've arranged for you people that it will be a live practical class. Live in the sense that I'm going to perform the things in front of you over here in the lab of the school itself, and to show you some experiments. Theory classes continuously going on. Probably there is a probability that you might be bored with those theory classes. So this will be a just changeover, uh, refreshment time. Okay. So a couple of experiments I'm going to perform, and I hope you will definitely enjoy that one. The first experiment I'm going to perform is, you have probably, okay, let me just rub this one out. Let me just rub this one out. And the first experiment will be, you have heard the name of this problem. I hope so. You have heard the name of this test. This is called the brown ring test. This is called the brown ring test. This experiment name, you have heard this. And if not, definitely in the upcoming classes, you'll definitely heard this name of this test. What this test is? This test is basically all about, this test is all about nitrates. This test is all about nitrates. So whether a sample is containing nitrate or not, we can confirm this by this experiment, brown ring. This is a very good test. It's a confirmatory test which gives us the confirmation that a particular sample is, whether that sample is containing nitrates. Nitrate means this symbol, I hope you know this, NO3 with a minus. So any sample, whether it's containing this particular anion or not, we can carry out this particular test and we can go for a confirmation. How that is performed? We need few things. The first, the salt itself. That means salt solution. So whichever the salt is, we are focused on at this particular salt. We want to confirm that whether it contains the nitrates or not. That's all solution we need. Plus, we will go for ferrous sulfate, once again solution. This ferrous sulfate has to be freshly prepared. Freshly prepared. Okay. This ferrous sulfate has to be freshly prepared. All right. Now, if I add this two, followed by this addition, both these two. First, we will add this two, but in equal quantities. Equal quantities. Okay. We need this. Then what we are going to do? We are going to add concentrated H2SO4 slowly, very slowly, very slowly from the sides, very slowly from the sides. We need to add sides of the test tube or the container, whichever rather the apparatus you're using to carry out this experiment. We are going to do that. After doing this, if a brown ring forms, then definitely the sample contains, the salt contains nitrate, and if it does not contain anything, no nitrate present, then it will be no color change and no ring formation. But be careful, your hand has to be very much steady. Otherwise, if it, well, a little bit of jerk within the solution mixture, the entire ring will be, the entire ring, you will see the entire solution mixture will turn brown. So without the ring at a particular point, this ring will form basically at the junction of this mixture and this acid. The ring will form at the junction of this mixture and this acid, sulfuric acid. If there is a disturbance, slightest of the disturbance, then the ring will not form. The entire solution will turn brown. So let's carry on with the experiment. This is, I have taken one salt sample. This is a salt solution which is containing nitrate. Hope so. And I have taken this ferrous sulfate solution. Equal quantities, you can see it out. You can check it out. Equal quantities. Now I'm going to mix this together. Okay? I'm going to mix this together. This completely, I'm just shaking this and thoroughly I have mixed. I have mixed this one thoroughly. Clear? Now, what I'm going to do is, I'm going to add, as I said, this mixture now, freshly prepared. This mixture, salt solution, ferrous sulfate solution, and equal quantity. Now I'm going to add concentrated sulfuric acid. Be very careful while using this acid. You can see over here, concentrated sulfuric acid. It's a very, very dangerous acid. So you should not use this acid or handle this acid with bare hand. Always use droppers. Always use droppers. So I'm also using a dropper, concentrated sulfuric acid. And if you see concentrated sulfuric acid, it's very some sort of oily type thing. It's an oily liquid, and hence the name, you can find it out. It's called the oil of vitriol. You will find this name in your that common name list also. Concentrated sulfuric acid, since it's oily liquid, it's called oil of vitriol. So now I'm going to add sulfuric acid very slowly along the sides of the test tube, and you will expect a brown ring. I hope you can see there is a brown ring which has formed, but since my hand is trembling, for that reason this ring is basically got slightly messed up. My hand is slightly trembling, for that reason the ring got slightly messed up. Otherwise the ring would have been a perfect ring at the junction of the two liquids. But this confirms that this solution, the salt solution which I took, contained nitrate. So nitrate is a confirmatory. As you can see, the sulfuric acid is heavier, which is at the bottom, and the salt solution, the mixture, the salt and the ferrous sulfate, the mixture, that is lighter, it's at the top. And the junction of the two liquids, and at the junction of the two liquids, you can see the brown ring has formed. Slightly messed up, since as I said, a slightest of a disturbance will disturb the solution itself. So since my hand is slightly trembling, for that reason it is slightly messed up. Otherwise perfect ring would have formed. Okay, this is also quite clear, the ring has formed. So this is how we confirm nitrates. This is how we confirm nitrates. Okay.
So you have seen that how the brown ring has formed, and though it's a slightly thick one, but as mentioned over there, that the hand was slightly shaking. But if the mixtures are not disturbed, and if the mixtures are very gently poured and mixed together, that means the acid and the sample mixture, then the ring would have been much more thinner. So it's a very fine thin or color, rather fine thin ring forms at the junction of the two liquids. So if I want to go into the reactions rather generally, there is a complex formation reaction happens between at the junctions of the two liquids. So here is the reaction that we are having. We took sodium nitrate solution, and with that we added actually ferrous sulfate, freshly prepared, followed by the sulfuric acid concentrated is there. So there it goes. The actual one, it's not that ferric sulfate, sodium sulfate is okay, but the point is we are having this nitric oxide, this NO formation inside this liquid mixture within the medium itself. So that actually combines with the hydrated ferrous sulfate. Sorry, hydrated ferrous sulfate, and there it goes, the formation of a complex. There is you can see there's 5 molecules of water followed by that NO and iron, and then the sulfate radical is there, and then water. So that this complex formation, this FeH2 whole 5 NOSO4, that's complex. This compound, the formation is basically the brown ring, which forms at the junction of the two liquids. So, and leading to the confirmation that nitrates are present inside the solution mixture. So that's all for today's class. We'll catch you up with another few more experiments in the upcoming classes. So stay tuned for the next classes. Thank you.